Hello, and let's continue our discussion on the methods for proving triangle congruence. And this time, let's talk about the Pythagorean theorem. It says that the square of the length of the hypotenuse of a right triangle equals the sum of the squares of the lengths of the legs of the right triangle. And that is c squared is equal to a squared plus b squared. I know that you have encountered this theorem already in your basic education days, but in this particular lesson, let's try to show two proofs for this theorem. One is the intuitive proof and the other one is the algebraic proof. Actually, there are so many things and there are so many techniques on how to prove the Pythagorean theorem, but we will limit our proof for the time limitations. So first, let's have the intuitive proof. Okay, so what I will do is to draw a triangle, a right triangle to be precise. And let's say that the length of the shorter leg is 3 units. The length of the longer leg is 4 units. And the length of the hypotenuse, which is the longest side, is 5 units. Okay. Now, say for example, I will extend this portion so that I will find its area, and suppose that this one is a square. Okay, so this square has 3 units, so definitely the square has how many square units? So we are expecting 9 square units for the shorter leg. Okay, so again, we'll do the same for the longer leg, and suppose that this is a square, and since this is a square, so we know that the area of a square is side squared. And so since the longer leg has 4 units, so we are expecting how many square units for this side? We have 16 square units. Okay, and finally, for the hypotenuse, so we extend it as well, and let's find its area. And since the length of the hypotenuse is 5 units, so there we are expecting we will have 25 units in this section. Okay, 1 2 3 4 5, then we have here 1 2 3 4 5. Okay, so we know that this side, the side in the side that is in the shorter leg is 9 square units, and for this portion is 16 square units, and for this portion is 25 square units, so that we can see here the relationship between the area. We know that the area from the shorter leg, okay, plus the area from the longer leg is equal to the area from the hypotenuse. And that is, we know that is 9 plus 16 is equal to 25. And which is, we know that 25 is equal to 25. And we're able to show the proof of this theorem intuitively. Okay? Next, let's have the algebraic proof. Okay? So this time I will draw a square. Let's draw a square. And let's draw another square from the inside of this larger square. Okay, so this one is a right angle, this one is a right angle as well, because that's a square. We will talk about that in chapter 4. So let's name all the bisections as, for the shorter leg, let's name it as A. All the shorter legs as A. And A here. And let's name the longer leg as, let's say, B. Okay, and then the length of, or the side of the square inside the larger square, let's name that as, let's say, C. Okay. Now, so we know that the area of the square, the formula for finding the area of the square is side squared. And of course, the area for finding the area of a triangle is 1/2 base times height. Okay? So again, let's find the area of the outer square. Okay? Area of the outer square. Outer square. We know that the area of the outer square is side squared is equal to, that is actually, we know that S here is equal to the side of the square, the outer square is the composition of the lengths A and B. So that is A plus B. So therefore, side squared is A plus B. Quantity squared. Okay? And let's find this time the area of the inner square. And that is S squared is equal to, since the length of the sides for the inner squares are C, then we say that this is C squared. Okay? And we know that the side is equal to C. Now, so that let's also find the area of the triangles. Okay? And that is actually, how many triangles we have here? We have 1, 2, 3, 4 triangles. Okay? So that is 4 times the area. So which is, and we know that the area is 4 times 1/2 of A times B. Okay? Because that's base times height. So you could interchange A and B, but this time I will be using the base as A and the height as B. Now, to simplify this is 2AB. Okay? Now, we know that the area of the outer square, okay, the largest area, the largest square or the outer square, the area of the outer square is equal to the area of the inner square, and the area of the 4 triangles that we have. Do you agree? Okay? The 4 areas of the triangle. And this is actually simply saying that the area of the outer square is simply A plus B quantity squared. Okay? Is equal to the area of the inner square is simply saying we have C squared plus the area of 4 times the area of the triangle is 2AB by substitution. Okay? And expanding the left part of our equation by squaring the binomial, we have here A squared plus 2AB plus B squared is equal to C squared plus 2AB. Okay? We can cancel out 2AB. We can subtract both sides by 2AB and can cancel it out. And therefore, what we have is C squared is equal to A squared plus B squared. And we're able to show that the theorem holds. Okay? Let's talk about the square root property. And this property is actually helpful in order for us to solve for the lengths of the given right triangle. So let x represent the length of a line segment, and p let p represent a positive number. If x squared is equal to p, then x is equal to square root of p. Take note that we are only taking the positive square root, or what we call the principal square root. This one is the principal root. Okay? Principal root. Or that is the positive square root. So why are we not taking the negative square root? Because take note that we are talking about the length of a line segment. Okay? It's the length of a line segment. And since that is a line segment, there is no negative length of a line segment. So therefore, we only take the principal root. Okay? Let's have an example. Find the length of the third side of the right triangle, given that we have C if A is equal to 6 and B is equal to 8, and for B, find B if A is equal to 7 and C is equal to 10. Okay, let's have our solution. So, C is unknown, A is 6 and B is equal to 8. So for letter A is given, which is 6, B is given, which is 8, but C is unknown. So that is By using the Pythagorean theorem, we have c squared is equal to a squared plus b squared. Then substitute. We just need to substitute. A squared is 6 squared plus 8 squared, and this one is c squared. So we have c squared is equal to, we have 36 plus, what we have here is 64, and 36 plus 64 is 100. So c squared is equal to 100. Then let's apply here the square root property. Okay, we raise both sides by a square root so that the square root of c squared is c, and the square root of 100 is 10, and therefore c is equal to 10. Okay, for letter B, B is unknown. If A is 7 and C is equal to 10, so A is 7, C is equal to 10, and B is unknown, which is what we are to find. So we know that the formula is c squared is equal to a squared plus b squared. Then let's derive a formula so that we can find the value of b. So we know that we subtract both sides of the equation by a squared. So what we have there is b squared is equal to c squared minus a squared. And let's apply our square root property. So this one will be b is equal to the square root of c squared minus a squared. And this formula will be used to find the length of b. So just substitute. We have here the square root of c squared is 10 squared minus 7 squared, which is the value of a, which is, we have 100 minus 49 is actually square root of 51. Okay, and we can no longer simplify this, but actually if this is simplifiable, if this one is simplifiable, we can still simplify it. Okay, but since the radicand is no longer simplifiable, then so be it. But you can also convert that in terms of decimal, and the value of it is approximately 7.14. Okay, and that is how the Pythagorean theorem is being applied.